We can solve a rational equation if we multiply all terms, if we multiply both sides, by the least common denominator. That will clear out the denominators and give us a simpler equation to solve. So in this example, we can multiply each term by 10x. So we get 10x times 5 divided by 2x minus 10x times 3 divided by 5 equals 10x times 4 divided by x. Simplifying the numerators a little bit, we get 50x over 2x minus 30x over 5 equals 40x over x. The first fraction here simplifies to just equal 25. 50 divided by 2 is 25. The x's cancel. Here, 30 divided by 5 is 6, so we're left with 6x minus 6x. And on the right-hand side, simply 40. So this is a much simpler linear equation we can solve by subtracting 25 to the other side. That leaves negative 6x behind. Negative 6x equals 15. And then I can divide both sides by negative 6. So we end up with x equals negative 15 over 6. Again, with a fraction, the negative sign, it could either go in front of the whole fraction, or it could go with the number in the denominator or the number in the numerator. That's the same as negative 5 over 2. So we do have to be a little bit careful with rational expressions. We can sometimes introduce false solutions. This one is not a false solution. The only problem would be 0, because plugging in 0 would turn the denominator, some of the denominators, into 0, plugging in 0 for x. We can see if we simplify this to negative 2.5, which is the decimal version of that answer, we could check and see that that is a solution. 5 over negative 2, or rather 2 times negative 2.5 minus 3 over 5. Simplifying that becomes negative 1, because we end up with a negative 5, a 5 over negative 5. Negative 1 minus 3/5. Putting that together as a single fraction, that's negative 8/5. On the other side, if I plug in negative 2.5, I get 4 divided by negative 2.5. But that's the same as 8 over negative 5. And so both fractions are equal to negative 8 over 5.